Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. Hope you are enjoying the lectures on engineering drawing and other subjects. If you want this and many more interesting topics, please do subscribe this channel. If you like this video, please hit the like button. That will keep me motivated to create more such videos in the future. Now let's see the conic sections with the different methods, right? Let us see particular ellipse. So here, suppose we want to draw the conic sections by arcs of circles method. Okay, so here you are given the AB, the major axis, and the minor axis. We have drawn this and drawn a perpendicular bisector and marked the minor axis, and O is the intersection point. F1 and F2, we can find out F1 and F2 with the AO as radius, C as center. If you draw arcs, we get F1 and F2. That's how we got this data so far. Now we have to draw the ellipse, complete curve. Now how? Let's take one point here beyond F1, right? On between F1 and O, we take some point here. Say I call it as 1. Now I take A1 as radius and F1 as center. I draw an arc. Okay. And now 1B as radius, F2 as center. I intersect this arc here. I draw an arc getting one intersection point. So if you see this one, I call this point as P1. And if you see this distance is A1 and this is B1. Okay, the meaning of it is the point P1 is on the curve ellipse. Why? This A1 plus B1 is nothing but A1 plus B1 is nothing but major axis. That's why this point P1 is on the curve. So using this principle, the characteristic of the ellipse, we are going to construct the ellipse. Now, with the same radius A1, right? Not only here in the top, here we can draw an arc here, F2 as center, draw an arc, right? And 1B as radius, F1 as center, draw another arc intersecting here. We get a point, intersection point, call it as P1 dash. Okay. Now, this is A1 and B1. So, with the same A1 as radius, F1 as center, one arc here, 1B as radius, F2 as center, another arc here. So this is P1 double dash, I call it as, and this is A1, this is B1. Again, this point P1 double dash is also on the curve. Using the same principle, so A1 as radius, F2 as center, draw an arc, and 1B as radius, F1 as center, draw another arc. So we get a point here. We call it as P1 triple dash. Now A1, B1. So all these 4 points which you obtained here with the for just 1 point on the axis here are all on the curve ellipse. Similarly, you can take any number of points. Suppose if I take 2, right? A2 as radius, F1 as center, draw an arc. 2B as radius, F2 as center, another arc. You get 1 point. Okay. This one. Similarly, with F1 and F2 as radius, F1 as radius, A1, A2 as distance, right? And 2B as radius, F2 as center, you draw arc. So we get 2 arcs here, one single intersection point. Now, similarly, we draw the curve here in the bottom also, right? A2 and B2. Similarly, here another point. Likewise, for 1 point you take here on the curve, right? Beyond F1 and O, between these 2 points, if you take 1 point, we get 4 points here. Like, So depending on the number of points you take, here you get a number of points and join them by a smooth freehand curve, and we get a curve like this. That is the required ellipse. Because we are drawing this by using a number of arcs, we call this as a method as arcs of circles. Okay. So you got the ellipse. So just I have erased the construction lines to be more clear. And now I want, if you want to draw the tangent and normal at any point, you know that method. You take that point and join F1 and F2 and draw a perpendicular bisector to that arc. You get the normal and draw the tangent. You get the tangent. Like that you can get it. Next, we are given the major axis and minor axis, and using the concentric circles. You know the concentric circles means having one point as the center, you draw two circles or any number of circles. They are said to be concentric. So using this concentric circles method, we are going to construct the ellipse. So we take the major axis AB, minor axis CD. They two intersect here at O, the center point here. O as center, right? OA as radius, draw a circle, right? And OC as radius with O as center, draw another circle. Okay. And now I am extending this line CD further, and I want to divide this part, this quarter circle here, into number of parts. So here I am dividing into 3 equal parts. That's why actually I have drawn diameter lines. Okay. That is also dividing this part of the quarter circle. Okay. Now let us mark this point as this diameter line intersecting here at 1, right? And 2. I'll draw a, and of course, because we have made 3 equal point, 3 parts, we marked the third point also. Now, you can do the same procedure for all the remaining 2 quarters also. So here, what we have done is we have drawn the diameter lines, divided the circle into number of equal parts. Okay, 12 parts we made it here. Okay, now let us take the 1 quarter, this part. Okay, now this diameter line is intersecting at 1 dash here. This inner circle at 1 dash, outer circle at 1. 1 dash, 2 dash here, right? At 1, I draw a line, vertical line here, right? And at 1 dash, I draw a horizontal line. These two are intersecting here at some point P1. Similarly, you draw a vertical here at 2 and a horizontal at 2 dash. These two intersect here at P2. Okay. So these P1 and P2 are on the curve, ellipse. Similarly, we can follow the same method, same procedure for the remaining quarters also. Okay. So the curve starts with A here. These 2 points will be on the curve. And this is because the point CD is the minor axis. This point C is on the curve, right? So you can follow the same procedure here in the other quarters, drawing a vertical line and a horizontal line. You get 1 more point. Similarly, here I get a P5 and here another point here, right? P7 and P8, okay, and P9. Actually, this point P6 is not here. P6 should be, okay, P6 is at the major axis. All right, fine. So P6 is on the coinciding with B, and P7, P8. P9 will be coinciding with the minor axis, D point. Similarly, in the other, these quarters also, a vertical line and a horizontal, you get P10, a vertical and a horizontal, P11, P12, right? Coincides with A. So we got 12 points here. Join all these points by a smooth freehand curve. you get a beautiful curve called ellipse, right? So like this, because we have used the concentric circles to get this one, we call this method as concentric circles method. Now, there is another method called oblong method to construct the ellipse. That is, you take the major axis and minor axis, they intersect at O. Now, we instead of drawing circles like earlier case, we draw lines passing through this A, B, C, D like this. Okay. Now, we got a rectangle. We got a rectangle here. Now, I divide this AO, this part into some equal parts, some number of equal parts. So say 1, 2, 3, 4, 4 parts. I mark them as 1, 2, 3 and 4. Similarly, here from A, this vertical line, I divide this into the same number of equal parts. Here we made it to 3 equal parts. Here also we make into 3 equal parts. Okay. Sorry, 4 parts. 4 parts. Same 4 parts are done here on the from A, and these should be marked as 1 from, these are marked from A, this side, 1, 2, 3, 4 like this. And from A, this side also 1 dash, 2 dash, 3 dash like this, right? So now let us join this point C with 1 dash, 2 dash and 3 dash. Okay. Now we'll start with the D, join 1, D1 and extend this up to this first line, C1 dash line. Okay. D1 is extended up to this first line. Similarly, we get an intersection point here, right? Similarly, D2 extend up to second line, D3 up to third line. We get 3 intersection points here like this. Okay, all these 3 points are on the curve ellipse. Similar procedure can be followed here on the other 3 parts of the rectangle to get them, and you will be getting the curve like this in the other 3 quarters also. Okay, or else you can just draw horizontal lines from this P1, P2, P3 and extend them on the right side and mark the same distances, the same distance from here on the right side. Like this also you can get it. So you get P1 dash, P2 dash, P3 dash like this. The same procedure can be done in the other 2 quarters. Like P1 is extended up to here and drawn lines, extend them in this quarter also like this. Mark the same distances. The same distance is marked here. This same distance is marked here likewise. Now they are called P1 double dash, P2 double dash, P3 double dash. Join these points, you get another beautiful curve here in this quarter. So the same thing is extended on the right side also. This 4th quarter, you get for 3 points. Joining them, you get the complete ellipse. This is called ellipse by oblong method. Now, suppose instead of giving perpendicular lines AB and CD, major and minor axis, here suppose you are given a rhombus, right? 2 lines are given here at some angle, AB and CD. These are not major and minor axis. Here you are given just 2 lines at some angle, maybe 80 degrees angle or something like that. Now, instead of constructing a rectangle like earlier one, we construct a rhombus like this. We construct a rhombus. We follow the same procedure as we have done in the earlier case, and here we divide this part into 4 equal parts, mark them as 1, 2, 3, and joining this with C, we get this one. We get these 3 lines. Divide this AO also into the same number of 4 parts. If you take 6 parts, you divide this also into 6 parts. So 4 parts are taken here, and these must be named from A only. These are named from A, 1, 2, 3. From A, this side 1 dash, 2 dash, 3 dash, like this. Join D1 dash and extend up to first line. D2 dash up to second line. Okay, P2, you get 1 point. P3 dash, D3 dash, you get P3. Likewise, you get 3 more points here, and likewise you follow the same procedure in the other 3 parts, you get an ellipse. But here, if you observe, this AB are not the is not the maximum diameter line, maximum line which can be fit inside this rectangle, this ellipse. So we call a major axis when a maximum line, right? Maximum length of line which is fitted inside this curve only as the major axis. So we have to find out the major and minor axis. These AB and CD are not major and minor axis. So what we do is we take say OC or OD as radius, O as center, we draw an arc here on this curve. We get some points, say P. Okay, P is joined with C here. P is joined with C. And now, parallel to PC, passing through O, we draw a line here. Parallel to PC, passing through O, we draw a line, right? That is EF. We call it as EF. Draw it, that is the minor axis. Okay. Perpendicular to this, you draw a line passing through O like this. This is the maximum line which can be fit inside this curve. So this is called the major axis. So like this, we can get the major and minor axis of the curve when you have inscribed, when you have drawn the ellipse inside a rhombus. Okay. So we have seen 3 types of methods to construct an ellipse. In the next video, we are going to see the construction of a parabola. Okay. Hope you had understood this topic. And if you have any queries or any doubts or suggestions, please do comment and do subscribe to the channel. Thank you very much.